Assalamualaikum and selamat sejahtera. My name is Danial bin Rahmat. Today I will present my final year project title, which is Surface Tension Analysis, Feature-Based Surface Data Leveling. Surface tension analysis is a crucial part of manufacturing because it helps to assess the functional topography of products and enhance their performance and the functionality. There are various microfabrication processes that can produce complex 3D surface or shapes, which can be challenging to precisely measure using traditional methods. In this study, we explore an alternative method for leveling surface topography data by using surface topography feature as a reference. Plane leveling by projection is a technique often used in surface metrology to address discrepancy between the surface of a specimen and the measurement plane on the instrument in the x and y direction. However, this approach can cause distortion in the geometry of the specimen and may not suitable for high precision measurement on the surface with steep slopes. A systematic approach in our study which include four main phases: initial research, data preparation, algorithm development, and evaluating the algorithm. The technique applied is the least square mean substitution method, which involves fitting a least square mean plane to the surface using the least square method, calculating the difference between the reference plane and the least square mean plane, and subtracting the uh, least square mean plane from the surface to obtain the level surface. Surface tension analysis is a crucial aspect of manufacturing because it helps to evaluate the functional performance of the components and improve product performance. The texture of a surface is made up of various elements that may or may not be important for its function. The feature of the surface topographics refers to the new features parameter term that has been introduced to describe a parameter based on the selecting topography features such as points, lines, or regions that are identified on the surface using watershed segmentation. The watershed technique is used to partition a region based on its features and characteristics. It involves simulating the flow of the water over a landscape and using the points where the water surface of different pits meet as the dividing lines between different areas. This technique is useful for analyzing surface topography and can help to identify and divide region of interest into smaller and homogeneous parts. Every point on the hill can be reached by following an upward path that ends at a unique peak. If the upward path from a point leads to another peak, it means that the peaks belong to another hill. The boundary of a hill is defined by a coastline, which is enclosed all the points to the hill. A pit is a lower point of the surface that is surrounded by higher points. The area of a surrounding pit is called a dale. From any point on the dale, there is a downward path that leads to the pits. In this study, aerial topography leveling is focused, which is a process used to remove the overall slope or the tilt of a surface from a measured height data. This is often done in a surface metrology to isolate the local surface features and eliminate the influence of overall slope on the measurement. There are several different methods that can be used to level a surface, including simple subtraction of the mean height, rotation, and translation of the plane to the x and y plane, and more complex techniques such as least square fitting. The choice of the method that will be applied in the study will depend on the specific requirement of the measurement and the characteristic of the surface that being analyzed. In general, leveling by rotation and translation is more accurate, but it can be more complex to implement and may not preserve the uniform spacing of the measured point. By leveling subtraction is simpler and preserve the point spacing, but it can introduce some distortion into the measurement. Leveling can also be important in surface metrology because it allows for more accurate and consistent measurement. For example, if the surface being measured as an overall slope, the measurement may be biased by the slope, leading to inaccurate result. By leveling the surface, it is possible to eliminate this bias and obtain more accurate measurement. Additionally, leveling can help to standardize the measurement and make them more comparable to the other measurement taken on the different surface or under different conditions. In the literature review, this study suggests an approach for leveling that involves using a subtraction method to preserve the structure of the image data as much as possible, and then correcting any distortion by reconstructing the correct position of the point as if they have been rotated. This method can handle the leveling problem caused by the distortion. The least square method is commonly used in a surface methodology to analyze height data, but it ignores the x and y coordinate. One way to account for this coordination is to remove the mean plane by subtracting the average height from all the points, but this can introduce distortion, especially for surface with low aspect ratios. Alternatively, the mean plane can be rotated to the x and y plane, which to preserve dimension and shapes, but the changes between spacing in the x and y direction. It is important to consider the grid spacing when analyzing height precision measurement, as the x and y spacing may not be the same. A more accurate method is to use a rigid transform to align the mean plane to the x and y, which preserve dimension and shape but does not arrange the resulting point on the regular grid. This method, called leveling by rotation and translation, may introduce some distortion, but it is usually acceptable for like roughness measurement. For precise dimensional methodology tasks, the leveling by projection, which is the non-rigid transform method, may not be suitable. The other studies suggest that when computing the least square mean plane, which is known as global leveling, using all available data points in the surface data topography. This is typically appropriate for surface with a relatively uniform topography, but may not be suitable for analyzing specific areas or for topography with large uneven features such as protuberance or indentation that are asymmetrically located. In these cases, using all the data points may not be produce accurate result. Other studies suggest that when analyzing specific feature, it can be helpful to use background regions, which the areas surrounding the features of interest, as a reference to construct the least square mean plane. This allows for more targeted analysis of the features rather than using all the available data points. To improve the robustness and reproducibility of the analysis process, it is recommended to use algorithms that can automatically identify and select regions that are more suitable for use as a reference plane. This technique is called selective leveling. This can provide more reliable result than using all available data points or relying on manual selection of reference regions. This literature review suggests that the least square mean is a more efficient method for leveling surface texture, but further research is needed to fully understand the approach, such as the algorithm or tools used for this leveling. The difference between the global and selective leveling are typically only significant in situations where the portion of the characterization process involved in the image processing technique. The goal of this project is to develop an algorithm for leveling surface topography of a micro electromechanical system using existing methods such as computing the least square mean plane. The algorithm will be tested on simulated surface topography data. The objective of the studies are data preparation of the surface tension measurement taken using a non-instrumental method such as digital imaging and data of simulated topography data of micro electromechanical system, and develop the algorithm using existing techniques that can automatically identify and select the region of the surface that we are interested and make it more suitable for use as a reference plane in computing and subtracting with the least square mean plane. Finally, the objective is testing and evaluating the algorithm by comparing the result with commonly used method to evaluate its efficiency. In this research, it is limited to the analysis of the flat plane, which is the context of the leveling micro electromechanical system. The least square mean method is used to level an area surface texture by fitting a plane to the surface using the least square method. This method minimizes the sum of the square difference between the observed values and the values predicted by the planes. It is used to obtain a precise and accurate representation of the surface texture, and the resulting plane serves as a reference for measuring the height of a surface and all other height with the surface are measured relative to this plane. The study will be conducted using a MATLAB software which can be used to analyze and quantify the texture of the region in the image based on variation in pixel intensity value. The proposed methodology for analyzing the surface texture of area surface involve four main phases: initial research, preparation, algorithm development, and evaluation the algorithm. Initial research involve conducting a literature review to identify existing research on leveling methods and summarizing the key finding and algorithm identified. Data preparation involve developing a simulated topography surface texture of micro-electromechanical system and pre-processing the data to make it more suitable for analysis, which may involve filtering the data to remove noise or outliers. Algorithm development using MATLAB software involve gathering the existing algorithm from the literature review and executing the development algorithm based on the research finding. Finally, testing and evaluating the algorithm involve comparing the result obtained using the new algorithm with those obtained using other leveling methods to identify areas for improvement. In this study, the least square mean subtraction method is used in the area surface texture leveling to remove the systematic errors from the surface height measurement. The least square mean plane is first fitted to the surface using the least square method. The least square method use the difference between each measurement point and the least square mean plane will be calculated. This difference also known as residual represent the deviation of the surface from the least square mean plane. By subtracting the least square mean plane from the reference surface, the resulting level surface is obtained. The reference plane used for this subtraction may be chosen based on the specific requirement of its application. To achieve this study, simulated surface topography data of micro-electromechanical system surface generated for further algorithm development testing. This simulated data can be regenerated by using existing surface topography texture of micro-electromechanical system and replotting the X and Y data into the raw data format, which is the data format will be in .cos file format. The surface topography can be generated, which can be read by using a software called SAMI. It will generate the simulated surface topography. In this study, the level plane of a surface texture topography is obtained by subtracting the least square mean plane from the reference plane. The least square mean plane is a mathematical model that represents the average or mean surface of the surface texture. By subtracting this plane from the reference plane, any deviation or irregularities in the surface are removed, resulting in more even surface. But before implementing the leveling algorithm, it is important to ensure that the algorithm is suitable for this study by conducting further analysis. It is important to plan the final year project because it helps to visualize the project schedule and track the progress of the task. It can help to identify any potential bottleneck or delays in the project timeline and make necessary adjustment to keep the project on track. Overall, a Gantt chart is an essential tool for planning, organizing, and managing a final year project effectively. That's all for me, and thank you and salam sejahtera.